Hello everyone, welcome to this YouTube. This is teacher Stephen Omondi Okech. Today we are going to discuss about the metals. Metal is one of the topics in Form 4, and it is a topic that needs a thorough and synthesized presentation. And I'm going to ensure that nothing is left. I'm going to discuss anything that a mind of an examiner can contain. And I'm going to ensure that everything is covered. So work with me, like this video, subscribe to this YouTube channel, click the notification bell. So whenever I post another video with synthesized notes, you can be able to be notified. You can get a notification and click and watch as we proceed on. Otherwise, thank you and work with me. So first of all, let us see the mapping of this topic in KCSE in paper 2 since 1995 to 2022. In 1995, the metal was tested from copper, and the question was in question 4. In 1996, aluminum was tested, question 3. In 1999, sodium was tested in question 4. 2000, lead was tested in question 2. 2002, copper also was tested again. Copper was tested again. It was retested in 2002, question 6. Aluminium in 2003 also was retested in question 5. 2005, sodium was retested in question 7. 2006, new metal was tested, that is iron, question 6. In 2009, iron was retested, which was question 7. 2010, zinc was tested in question 6. In 2014, aluminium was retested for the 3rd time in question 6. In 2016, aluminium was retested for the 4th time, question 5. In 2017, lead was retested in question 6. In 2019, zinc was retested in question 2. Then in 2020, iron was tested for the 3rd time. So in 2021, there was no metal tested. In 2022, there was no metal tested. In 2023, the probability of metal being tested is 0.97. The probability of it not being tested is 0.03. So to me, there is high possibility of it being tested in paper 2 in 2023. So which metal will be that? I'll be able to say it in at the end of this topic. I'll ensure that this topic is well covered. Check this one. So from 1995 to 2022, those are 27 years. In all those 27 years, the metal has been tested. The metal has been tested 15 times. To mean it has missed 12 times. That is from 1995 to 2022. So sodium has been tested twice since 1995 to 2021. Aluminium 4 times, iron 3 times with a percentage of 20, lead 2 times with a percentage of 13.33, zinc 2 times with a percentage of 3.3 recurring, copper 2 times with a percentage of 13.33 recurring. So the most tested ion since that year is aluminium, followed by iron. And the list are now the sodium, zinc, lead, copper. And I'll be able to say the reason to why they have not been frequently tested since since 1995. So let's see from here, the extraction of metals. The extraction, these metals, they are extracted from the earth crust. They are gotten from the ores. They are extracted from their ores, and those ores are extracted from the earth crust, the underground, through mining. It depends from where the ore is situated. The one that is situated below the earth crust, we have the methods which are used in extracting these metals. Let me pick the metals can be extracted from rocks called ores, and I've said these ores are gotten from the earth crust. The extraction of metals from their ores involves the following general processes. Very few metals ores are concentrated. There are some ores that if you want to extract them, if you want to extract some metal from them, you first concentrate them. We have different types of concentration, flotation, is one of the concentration. We'll be able to discuss that because you can also be asked to describe what is called the froth flotation. Very few are extracted without first purifying the ore to concentrate it. The process of concentration of an ore may include, you first remove the magnetic material using the magnet. We are trying to remove the purities. There are some purities which are magnetic. So you pass the magnet through the ore for the magnetic materials to be removed before you purify them. Then that is the purification. Purification will remove the purities which are magnetic through using what? A magnet. Then we dissolve the mineral in a suitable solvent. So after that, after removing those impurities which are magnetic, you now dissolve that mineral in a suitable solvent. For example, some we can use like ammonia. We do what you call them. We dissolve them in a hot concentrated base, which can be either potassium hydroxide or sodium hydroxide. Then also another one, we can also dissolve them in water as well. Water also is a solvent. For example, in extraction of sodium, realize that we'll be able to remove the impurities through flotation. Then we wash with water to remove earthy matters. From there, then we now do what is called the froth flotation. Very important. How is this process of froth flotation? This is one of the methods used in purifying metals. We are now purifying the metals. The ore is ground into fine powder. After you have ground the ore into fine powder, now you mix it with water containing a special oil, and this oil is from a pine or oil, and this oil acts as a frothing agent, and air is now blown into the mixture. The mixture of what? The mixture of the ground powder of the ore and water, and that water contains what? The oil, which is from the pine oil. Then the separation is possible because the different, they will have different densities. You will realize maybe the ore is more denser than water, and also we know that oil is immiscible in water. So they will form some layers. So due to their immiscibilities, makes them to have different densities. So the one which is less dense can be skimmed, and the one which is more dense can also be, if we use even separating funnel, the one which is more dense will be separated first. But if we use the skimming method, the one which is less dense can be skimmed out first. Then we have this important of oil coat every grain of the ore, making it hydrophobic. So you realize that the oil will now coat the what? The ore, the grains of the ore, and now will make it to be water hating, to mean it will be now floating on water. This creates two layers. A froth forms on top. So now we'll now form the froth. The froth is now that oil which is coated with not oil, but the ore, which is now coated with oil, making it to float. So froth, it forms a froth on the surface of water. Most of the mineral froth top with most of the minerals, and the waste materials or impurities at the bottom. So the waste materials and the impurities settle at the bottom of the container, maybe the place where you did place the ore into the mixer. The top layer with the metal of interest is removed and dried in readiness of the further processing. So the one that can be used, this process can be used in copper when we are extracting copper from copper pyrites, when we are extracting zinc from zinc blende, and also when we are extracting lead from galena. They must be concentrated this way first. Sorry, I made a mistake at first. I said sodium, we can also do this. No, here we use the metals which are less reactive. The metals which are less reactive. That is copper, zinc, and lead. Very good. The method of extraction of metals depend on their reactivities. So the one which are more reactive, we use electrolysis method. So the one which are less reactive can now be extracted by use of reduction, by using the suitable reducing agents, such as carbon true oxide, or coke, or charcoal. There's some of the reducing agents that can be used here. So the metals like sodium, aluminum, they are most reactives. They are most reactive metals. So therefore, they cannot be reduced by any other reducing agents like carbon, because they are above carbon in the reactivity series. So therefore, they cannot be reduced by any reducing agent like carbon. So that is why they cannot be extracted through reduction, but they can be extracted through electrolysis. They must be electrolyzed using the electricity. will be able to know that. So let's begin with the sodium. So sodium, the occurrence, how does it occur? Sodium occurs just naturally. So it can occur as a brine. Brine is just concentrated sodium chloride, which can be gotten in a salty seas or oceans. We have also rock salt. Rock salt is just solid sodium chloride. Solid sodium chloride is the rock salt, and the rock salt being now the chief ore of sodium, where the sodium can be extracted. We have also the trona. This trona is also called, says, quibernate, which is also sodium hydrogen carbonate, sodium carbonate hydrated. So it is hydrated sodium hydrocarbonate and sodium carbonate, especially gotten in Lake Magadi in Kenya. We have another one, it's called Chile saltpeter. Chile saltpeter. This is gotten in China, Chile, I mean. So that is just sodium nitrate. So the ores from which sodium can be extracted are sodium chloride and rock salt. So these are the ores of the sodium, where the sodium can be extracted, either sodium chloride and rock salt. But the chief ore is the rock salt. The chief ore from which the sodium is extracted is rock salt, because is the most, you can be asked, it is the most abundant and also requires very little purification. You can be asked to explain why the sodium is preferably extracted from rock salt. Then you will say, because the rock salt is the most abundant, or it is readily available. The rock salt is readily available, or so it also requires very little purification. Very important. Now let's check this one. Now let's go to extraction. How is now the sodium being extracted? Let's see how it can be extracted. Sodium is very reactive, therefore can only be extracted by electrolysis, just the way we said. It is electrolyzed. The ore is being electrolyzed, where we will have some ions moving to what you call the anode, another one moving to what we call the cathode. So it is extracted by electrolysis of molten sodium chloride, in a cell known as Downs cell. Hence, the process is commonly referred to Downs process. So sodium is extracted through the process known as Downs process. So now the Downs process takes place in a Downs cell, as shown in the figure below. In this figure, we have the fresh salt in, we have the chlorine gas out, we have the hood, we have the molten sodium, which has been extracted, we have ion pipe, we have the steel, we have the cathode, and also we have the fused sodium chloride and also calcium chloride. We have the then we have the steel diaphragm. So here, first of all, this fresh salt is what we call the rock salt, which is sodium chloride. So that sodium chloride, it is a solid. You insert it here through that to get into this place, and the following process takes place. The down cells consist of the following. We have the ion shell, line with the heat breaks, forming heat resistant walls. So if you come back, we have that this side. We have this thing called the downcell. It is lined. It is lined with the steel bricks. So those steel bricks they act as a heat resistance. So they resist the heat from getting outside. Why, you can also be asked why the purpose of using that wall, the heat breaks. They are heat resistance. So therefore they will help to maintain the sodium chloride in molten state. So it prevents the sodium chloride from being solidified. You can also know that. So that is that. So the ion shell lined with heat breaks, forming a heat-resistant wall. Its purpose is to maintain the high temperature so that the electrolyte does not crystallize. The electrolyte does not crystallize. And it is also contain the mixture of salt to be electrolyte. So electrolyte is now the sodium chloride, which is the rock salt. So because this sodium chloride will be heated to melt, so that the heat breaks will now make and maintain the sodium chloride in its molten state. So it will prevent it from doing what? From solidifying, solidifying. Then we have another one called carbon. Carbon is just the anode part of the downcell. So carbon is also made up of the graphite. Somebody can ask you, why is it made up of the graphite? Because the graphite is inert, to mean it does not react with the chlorine gas which will be produced there. So I want you to take that into consideration. Somebody can ask you, why is anode made of graphite? Or somebody can ask you, which metal is anode made up of? So it is graphite. Then give a reason to your answer. Because graphite is inert, therefore does not react with the chlorine produced at the anode. Very magnetic. So this is where the chlorine gas, the chloride ions are discharged to form the chlorine gas, which now escape through the hood. Then we have well, let me show you the anode. This is now the anode. That is the anode. So it is so the anode escape through that. There is a place. Oh, I think huku chini. So it escaped through that. So this is the anode here. That is the anode, this one here, chin, very good. So this is the anode. So in this anode, we have said that it is where the chloride ions are discharged to form the chlorine gas, and those chlorine gas now escape through this hood. And now they should not be allowed into the atmosphere, because it can also cause, it is very poisonous. Chlorine is very poisonous gas when inhaled. We have the cellular steel or ion cathode. So the cathode is made of ion. This is where the sodium ions are discharged to form the molten sodium. So cathode is negatively charged when the anode is positively charged. So because we know that sodium chloride is made up of two ions. We have the positively charged ions and the negatively charged ions. So the positively charged ions migrates to the positively charged, to the negatively charged electron, which is now the steel cathode or ion cathode. Then we have these chloride ions, which are negatively charged. They migrate towards the positively charged electrode, which is the anode. You should know that. Then we have the steel diaphragm or steel gauge. This steel gauge is suspended in between the steel gauge. This is the this is what we call them anode. This one also is the anode, which is made up of the graphite, no, not graphite, but the iron, sorry, iron or steel. That is that. Then in between, there is in between this one, and this one are called the diaphragm, the steel diaphragm or steel gauge. They are suspended between them, the anode and what? The cathode and the anode. You can see that this is the cathode, this is the cathode, this is the anode. This is the cathode, this is the anode. So it is suspended between the two. The reason why, because we know that here will produce ion called sodium ion, and here will produce what we call the chloride ion. So the main function of this is to prevent the recombination of the chloride ion and sodium ion to form, because if they recombine again, will now form sodium chloride, not the sodium that we want. So take note of that. So the function of this steel gauge or the steel diaphragm is to prevent the sodium ions produced at them, not produced but discharged at the cathode, from recombining with the chloride ion discharged at the anode. So that is the function of that, to prevent the recombination of the sodium ion discharged at the cathode and the chloride ion discharged at the anode. Very important. Then we have that. Then now there is something, if you come here, let me show you this one. We have the sodium chloride and the calcium chloride. So there is addition of this sodium chloride. The reason why we add sodium chloride, calcium chloride here is now to reduce the melting point of sodium chloride. Hence, the reason why it is very important to reduce it, the melting point, is because sodium chloride melts at a very high temperature. So when you reduce it, you shall have reduced even the cost of the electricity needed. Therefore, it becomes now economical. So the calcium chloride is added to the sodium chloride to lower the melting point of sodium chloride. You have to state that if you are told to give the reason why calcium chloride is added, you have to state that it is to lower the melting point of sodium chloride. Don't just say to lower the melting point. To lower the melting point of what? So you have to state that to lower the melting point of sodium chloride from about 800 degrees Celsius to 600 degrees Celsius. And somebody can ask you, why is it necessary to lower the melting point of the sodium chloride? Is to reduce the cost of electricity, hence making it very economical. So the advantage of lowering the melting point of sodium chloride is to save the cost of electricity used in heating, since it is economical. Very good. Let's see this. During now electrolysis, sodium metals forms at the cathode, because we said that sodium chloride, if we heat this, if we electrolyze sodium chloride, if we electrolyze this sodium chloride, we will heat this thing to its melting point. When it is melted, we'll now have aqueous. In this aqueous, each will form now two ions. Where we'll have sodium ions, we have also chloride ions. So, and also in downcell, we have two terminals. We have the anode. We have the anode. This anode is a positive electrode. Then we have the cathode. Cathode is negative electrode. So you realize that, go to the property of a magnet. The property of a magnet says that unlike poles attracts and like poles repels. So you realize that this positive charged ion will be attracted to the negative electrodes. And also the anode, which is, and also the chloride ion, which is negatively charged, will be attracted to the anode, which is positively charged. That is why a man cannot marry a man, but a man can marry a woman. So that is that. So the like poles attract. So this one is attracted to this, and this one is attracted to this. So when this one is attracted to this, the what will be formed here is the metal, which is sodium, or which in our case that is what we wanted to extract. Then we have also the chlorine gas, which will be formed at the anode, because the chloride ion will be discharged at the cathode. And now, just the way I've explained it, so where the chlorine gas forms at the anode, the chloride ions are discharged to form the chlorine gas. So we have this chloride ion. This chloride ion, which is discharged to the anode. And we said in electrolysis, I think if you did the electrolysis, we said that we define anode as is where the oxidation takes place. So we realize that this ion, which is discharged here, it is in liquid form because of that heat. The temperature in the temperature in the downcell makes it to be in liquid form. So it forms sodium chloride, producing one electron because we had only one electron lost, or gain, I mean, to gain one electron to become stable, because we know that chlorine reacts by gaining an electron. So that one is here, that one electron, and producing two chloride ions, which is now which forms now the chlorine gas. The two atoms here forming the chlorine gas. So for us, because here we have two chlorine, the two chloride atoms, the two chlorine atoms, now we balance. So we write 2 there. And now, being that now we have two chloride ions, and each produce 1 electron, 1 electron. So 2 shall have produced 2 electrons. So that is why we write 2 electron. We write 2 here in balancing the equations. I hope you have seen where this 2, you don't just come and write this 2 and you don't know where it comes from. So 2 comes from the two electrons which has been gained by 2 chloride ions to form chlorine gas. Very important. So if the oxidation state here is -1, and this the oxidation of an atom is always 1, so you realize that it has increased. The oxidation state has increased from -1 to 1, to mean it has been oxidized. The chloride ion has been oxidized to form chlorine gas. So that is why we say that at the anode is where the oxidation takes place. At the anode is made up of graphite because the graphite is inert and does not react with chlorine gas even at high temperature. Very good. At the anode, sodium ions are now discharged. We have this sodium ion, which also in liquid, because I said very well that there is high temperature in the downcell, which makes it to be in liquid form. So this ion is now reduced. At the cathode, there is a reduction. So it is reduced from 1 to 0. The oxidation of an element is 0. So that is that. So we have this one is being reduced to 0. So it reacts with, it gains. You know, at here, at the anode, we had 1 electron produced. So that 1 electron combines with the sodium ion to form what? Sodium, the molten sodium produce the molten sodium, and it is not solid, tafadhali. It is liquid because it is molten sodium. So it combines that. So don't come and balance. You don't balance using anything. So that is that I wanted you to understand that. But here should be 2. So here should be 2 because we produced 2 chloride ions here. The 2 ions, the electrons, because here we had 2. Because what you have to know, the electrons at the anode should be in balance with the electrons at the cathode, tafadhali. So here there was a mistake. It should be 2. But now don't balance here 2, 2. No, because we don't use electron in balancing the elements. That is that. So there should be 2. Then the molten sodium is less dense than the molten sodium chloride. The molten sodium is less dense than molten sodium chloride. Hence, it rises at the top of the cathode from where it is periodically removed. So if you check here, so we have said, because we know that sodium chloride is here, this is sodium chloride, molten one. But being that the sodium metal is less dense, is more dense, is less dense, is less dense. Sodium the molten sodium is less dense than sodium chloride molten. So it floats at the top. So being that it is floating on the top, it is now tapped out. You can see it is now tapped out periodically. So you have to understand that. So sodium, you can be asked to give the properties why the sodium metal can be separated from the sodium chloride. The property, you know that sodium chloride is more dense than sodium, and is less dense, sorry. Sodium chloride well, let's come back. Sodium chloride is more dense than sodium. So being that sodium is less dense, it will float, and you can now tap it. It will float at the top of the cathode. Yeah, because you know that it is produced at the what? At the cathode. The sodium is produced at the cathode here. Also, it is here. So you can tap it out because it is less dense than sodium chloride. Sorry for that. Yes. So the hood is used to collect the chlorine gas and channel it out, where it is tapped to prevent it from being released to the atmosphere, as it is poisonous and hazardous to the environment. I'd say that. We have also the liquid calcium, because we had the calcium chloride, which was used to reduce the melting point of sodium chloride from about 800 degrees Celsius to 600 degrees Celsius. So if you heat it, it will be in molten state, that calcium chloride, which also will be discharged at which, because you know very well, if you check calcium chloride again, calcium chloride, this calcium chloride also, we have two ions here. We have this calcium ion, which will be also discharged at the cathode. So being that we will have two ions discharged there, calcium and sodium, but our main interest is to extract sodium. So what will make it possible for sodium to be collected or to be tapped out in preference to sodium, to calcium? These are the reasons. So calcium can also be discharged at the cathode. The calcium is separated. Now we can now separate the calcium from the molten sodium, because one, calcium has high melting point compared to sodium. Calcium has higher melting point compared to sodium. So on cooling, it crystallizes fast, leaving sodium, which is tapped, not trapped, is tapped out. So calcium has higher melting point. So on cooling, it crystallizes fast, which makes it to be collected out fast. Then we have also calcium. Sorry, here calcium has lower melting point compared to sodium. So on cooling, it crystallizes fast, leaving the liquid sodium, which is now tapped out. Then we have also the calcium liquid, which is more dense than the molten sodium. So calcium liquid is more dense than molten sodium. Therefore, the sodium can be separated from it. So those are the properties which makes it possible. So sodium ions is preferably discharged instead of calcium ion at the cathode because sodium ions are lower in electrochemical series than calcium ions. You should also know that sodium ions are lower in electrochemical series than calcium ions. Sodium ions have higher concentration in electrolyte than calcium ion. So you can be asked, why is sodium ion preferably discharged instead of calcium ion at the cathode? You should be able to know that. These are the reasons which are here is totally different. Why the molten sodium is collected or tapped out at the cathode in preferable to calcium. You should be know that they are very different. So the advantage of the downcell, sodium metal obtained has higher degree of purity. The sodium metal gotten here has higher purity of 99.5%. So there is only some impurity of about 0.5. The starting materials such as sodium chloride is very cheap. Chlorine is obtained as a useful byproduct. So these are the advantages of the downsell in the extraction of sodium metal. One, sodium metal obtained has higher degree of purity. Another one, the starting material, which is sodium chloride, is very cheap. And also there is a production of chlorine gas, which is useful, which can be used in the manufacture of hydrochloric acid. And therefore, somebody can ask you which industry plant that can be situated near the sodium extraction plant. So you should know that the one that can be situated that is the manufacture of hydrochloric acid, because chlorine gas, which is a byproduct of the downcell process, is a raw material in manufacture of the hydrochloric acid. Also, the higher current of about 35,000 amperes is passed through electrolyte, which is a molten sodium chloride. Somebody can ask you why is a current about 30,000 to 40,000 amperes is passed through the molten sodium chloride. Yes, that is to decompose the ore, to maintain the ore in liquid state due to the resistance. We have also the environment effects of the downcell. The chlorine gas produced is poisonous when inhaled, a formation of gullies and noise pollution. Uses of sodium used in sodium vapor lamps to give a yellow light in street lighting. We have also, it is used an alloy of potassium. An alloy of potassium and sodium is used as a coolant in a nuclear reactors. Why? Because it has lower melting point and is a good conductor of heat. Sodium in the manufacture of sodium peroxide. Used in the manufacture of sodium peroxide, which is used as a bleaching agent, and sodium cyanide, which is also used in the extraction of gold. We have also molten sodium is used as a reducing agent in extraction of titanium from its chloride. So we will end it from there. So kindly like, share, comment, give the feedback. Any question that you ask, kindly ensure that you ask so that I demystify, I'll be able to respond to it. Any correction, anything that you think is not well captured, ask, I'll be able to give the reason to why. So I want to give you assignment. The assignment is this one. Go to to the KCSE past paper of 1999, try question 4. Go to 2005, try to answer question 7. I think you'll realize that all that we have discovered, the notes that I've given out are very perfect and will help you to summarize the sodium, and no question you will meet in sodium which we have not covered here. Like the video, subscribe to this YouTube channel. I'll be dropping all the metals, electrochemistry, with the analysis that will help you to understand this topic very well. Otherwise, have a blessed day, have a blessed time, enjoy chemistry. Chemistry is the easiest subject in the whole world, and ensure that you understand. If you know that you are a weak student in chemistry, choose the topics that you can answer at ease. Most of the topics from Form 4 and the topics in Form 2, that is under the periodic table. Periodic table, all the chemical families, structure and bonding, if you can, because they are in paper 2, those topics are merged as one question, in one question. Then come to Form 4. There are some topics which will never miss, like organic chemistry, electrochemistry. Come to now metals, I'm demystifying here, and probably it will be there 2023, and I'll be able to say which one according to the analysis that I've done so far. Otherwise, enjoy your time.